Hello and welcome to the Geo RGB community. Thiessen polygons can be used for a lot of different things, but today we are going to use them to create a Thiessen interpolated map with contaminated soils by zinc. This is a real example and I'm going to provide you all the data that we are going to use to create this video tutorial. It is interesting that every time I think in Thiessen polygons, what it comes to my mind is the romanticism windows chart. Maybe because of the shape of the windows, or maybe because of the colors, but that is what it comes to my mind. Also, what it comes is the optical mineralogy. You know, when you make an observation of a rock in a microscope, what you are going to see sometimes is these kind of shapes with these colors, these polygons, and also it's pretty similar to the Thiessen polygons, right? It is something that I would like to share with you. Okay, now what we are going to see is how the Thiessen polygons work, okay? How we can make the interpolation. What we are going to do first is define the spatial location of our samples. Then we are going to join a pair of samples with a segment. Then we are going to identify what is the center of this segment, and we are going to create the perpendicular line. Then we are going to join all the perpendicular lines in order to get the polygon, the limits of the polygon. Then at the center of this polygon, what we are going to have is our sample. Then we are going to assume that all the area of this polygon is going to have the same concentration as our sample. In this case, we are using samples, but you can use a lot of different type of parameters, okay? And the methodology is going to be the same. Now, let's go to see how to do the map. But first, let me remind you that Geo RGB community website has a Facebook page. In that Facebook page, you can follow us and you are going to get some content that you are not going to find in YouTube. Also, you can visit us at the Geo RGB community website at gscourse.online. Here you have a lot of resources. For example, all the softwares that we are using to do the video tutorials can be downloaded here in this page. Also, you have free courses and paid courses that you can take a look, and maybe if you are interested, you can follow any of them. And the good thing is that here, if you get enrolled in these courses, you can download the things that we are using, okay, in the courses. Now, let's go to start. Today we are going to be using the Muse River dataset. I already loaded in my QGIS session, but if you don't know how to do it, just go to Geo RGB community website, then go to courses. In courses, go to Geostatistics course for beginners, creating algorithms with R and QGIS, then click. And in lesson 2, get enrolled, then start the course. And in lesson 2 is this lesson. You have here how you can download this dataset, okay? You can also here have to download the CSV file, and just go to the website, click here to download the database, and then you are going to see also in that video tutorial how to load this data on QGIS and also how to create the shapefile. And that's what we have here, okay? If we go to properties, what we have here is information is a shapefile, and as you can see, this data set has a lot of different things. For example, we have the coordinates, they are in UTM, and also we have 4 different kind of metals, but the one we are going to use is the zinc concentration. This concentration is in ppm. Also, we have different other parameters, for example, distance to the river, type of soil, elevation, but we are going to use just the zinc concentration. Then first I'm going to load the satellite imagery. In this case, it's going to be Google. I'm going to change the color of these samples. We have in total 155 samples. For an orange color, for example, apply and OK. And you can see over here the distribution of the samples. That it's pretty regular, okay? It is pretty systematic, okay? The coverage of the samples is really good. You also can use the YouTube channel of the Geo RGB community to watch this tutorial related with the lesson 2 and to see how to get the data that we are using for the tutorial of today. And also, if you don't know how to use the Quick Map Services plugin, is this plugin that we use to load the satellite imagery, you can watch this tutorial. Let me show you. Is this tutorial. I'm going to leave the links at the video description, and in this tutorial you can see how to install and how to use the Quick Map Services plugin. Okay, now let's go to create the Thiessen Polygons. Then go here. It's going to be geometry tools, and here we have Voronoi polygons. Then click here. Select the layer where you have the information, is this layer. I want a buffer of 10%, and I'm going to save this file in a folder that I created, that is this one, with Thiessen Polygons, like this one. Save, and I'm going to run. I give a 10% of buffer. In that way, this is going to cover all the area, okay? You can play with the parameters to see in what way you are going to cover all the area. Then I'm going to move this one to the top. And as you can see, for each polygon, we have one sample, okay? And that's the area of influence of each sample. That's what we are going to consider. For example, here, if we have a concentration of 10, we are going to consider that all this area has a concentration of 10 ppm. Now, the next step is to put a limit for these polygons, okay? And the limit is going to be the river, okay? This one is the river, and it's going to be our limit. This limit is a geographic limit because it's the river, but could be also an administrative limit, right? For example, the limits of a lease, the limits of a factory, the limits of a parcel, and etc. Then to do that one, we are going to create a new shapefile. Then go to layer, create layer, and it's going to be a new shapefile. Then here, name is going to be saved in this folder, and it's going to be river. It's going to be a kind of mask, okay? Save. Then the geometry is going to be polygon. The reference coordinate systems is going to be the same as this one, 28992. Then let's go to change. For 28992 is this one over here. Is a projected coordinate reference systems. It is in meters, okay? Then okay, and then press this pencil to make the edition. Then I'm going to select this tool over here, and I'm going to digitalize the limits of the river. I'm going to pass the video faster. Now click right to finish. I'm going to put ID as a 1 and OK, and press the pencil again to finish the edition. Save. Now I am going to use this mask. Okay, maybe I'm going to change this one a little bit. Let me edit the layer again. I would like to move this one a little bit. Double click to move, and okay, that's good. Finish. Save. I'm going to use this layer to cut the polygon of Thiessen, okay? Then to do that one, go to vector, geoprocessing, clip, geoprocessing, clip, and here at the top is going to be the Thiessen Polygons, and here is going to be the river, and I'm going to save this one here as a Thiessen Polygons clip. Then save and run. Close, and now we can remove. We don't longer need this one. Okay, we can remove this one, remove. Okay. Now we are going to graduate the polygons according to the concentration of zinc. Then to do that one, go here, properties, go here to Symbology, and here select graduated. Then here select the value, that in this case is going to be the zinc concentration. And here you can select the ramp of color you want. That it's not important. Then we are going to use equal intervals. Then we are going to have 5. And here it is important to know what is the guideline in the area. Okay. In this case, I'm going to assume, for example, the guideline for a contaminated soils is assuming to be concentrations higher than 150 ppm. Okay, then it means that if you have values related with the zinc concentrations that are above of 150 ppm, we are going to consider that the soils is contaminated, and below it's not contaminated. Then that one is going to be the limit. Every country, every province, right, has their own guidelines, right, depending on the type of soil. In this case, for example, we are going to assume that this area is an industrial area, and then in this case we are going to use the guideline associated with the soils for an industrial area, and in that guideline say that above 450 ppm the soil is contaminated. Okay, then I'm going to establish this limit over here. Then I'm going to put here 450. Okay, 450. Okay, and then you can apply here to see how it looks like. And with the white areas we don't have any contamination. Okay, with the red is the worst one, and then with this kind of pink it's a little bit above of the guideline. Then we're going to change this symbology for something better. Okay, I'm going to show you now how to do it. First, let's go to start with this one. Double click over here, select this one, and here you can select the color you want. The solid line is going to be no pen, and also apply, and I want some, double click again, some transparency here. Okay, I want 80%, for example, or 70%. Let's go to leave 80%, and okay, and apply. And as you can see now, this red, it's a little bit transparent. For the next one, we are going to use a transparency of 60%, and we are going to change the color here. Also, we don't want line, and in this case what we want, it's a kind of lilac color, this one for example. Okay, and apply. Then for the next one, it's going to be, for example, a kind of orange, this one over here. That one is good. Here the transparency is going to be, for example, 40%, and also we don't want any line here. Okay, and apply. And for this one, sorry, over here, double click over here, we want a transparency of 20%, and this one we don't want any line, and the color of this one is going to be a yellow, for example. And okay, and apply, and okay. We cannot see the transparency because we have this layer. Now you can see the transparency. Okay, now let's go to edit the white color. Then go again, properties, double click on this one, I mean here at the square, at the symbology. Transparency for this one is going to be 10%,
and also we don't want any line here. Okay, and apply, and okay. Now let's go to see how we can create a perimeter of our investigated area. Then we are going to use the mask, then click here, go to properties, and in this case we want this layer to be transparent. Okay, transparent. Then here we want a dashed line, and the color is going to be white. Move this one to white, and this one is going to be 0.5. Then apply, and that's it. Now we are going to create the final composition. Going to name this one as a 1. Okay, then I'm going to bring the map, but click right, properties is going to be like this one. Okay, then bring the map with this option here. I'm going to cover all the extension, and the scale is going to be 20,000. I'm going to center the image with this option over here. I'm going to make a little bit of zoom with this one, and what I want is to remove the dots because I don't want the dots. Then I'm going to take here the dots, and I go here again to the composition and refresh. And now I am going to add the legend. Just click in this option over here and select an area. And let's go to see how we can make the legend. First, let's go to take this one out. And I don't want this one here. Then I'm going to remove this one. Also, I don't want this one. And I don't want this one, and I'm going to relabel this one. Okay, that one is going to be zinc concentration. Go here to this layer, rename, and it's going to be zinc concentration in ppm. Okay, that's good. Then go to the composition again, and let's go to edit this legend. Refresh to change the title, zinc concentration, as you can see. Now let's go here to add a background. That one is going to be transparent a little bit, something like that. And again, select the legend, and let's go to edit the font and text. Then for the subgroup, this one is going to be number 16 and in bold. That is for the title. For the zinc concentration, as you can see, now it's bigger. Also, I want to change this one to the center, and this one to number 14, maybe with bold also, something like that. And let's go to change the size of the symbols for 7 and 7 to make the ones bigger. Okay, that's good. Then we can move the legend here to the bottom. Also, we can add some text to the concentrations. For example, double click and you can add here not impacted. Then for the next one, go back, double click here, low impacted, and I'm going to change the other ones, but I'm going to pass the video faster. Okay, that's it. Now I'm going to place this one properly. I make a mistake here, impacted. Okay, that's good. Now we can export that one as an image or as a PDF, as it depends on you. Close, and I'm going to save here at the desktop. It's going to be this one. This format is good. Save. The resolution and the extension is good. Save. Double click to open. And let's go here. Is this one. And that's it. The map is created. Okay. As you can see, the resolution of the map, if we make bigger this image, is really good one. You have a really good resolution. And also you can change the transparency for these ones, because maybe is too much, even for these ones. That's up to you. But this way to make a interpolation, it's not very accurate, but it's a very fast way to see how the contaminant is distributed in your area. Okay, as you can see here, all the contamination, it's close to the river. Okay, we don't have any contamination at the middle. Okay, that one, these areas are clean. Okay, less this one and this one, but in general, all the contamination, it's next to the river. Okay guys, thank you very much for watching this video, and see you on the next lesson.